On tonight's homework, students are going to practice taking mixed numbers and making them improper fractions, and then also thinking about taking improper fractions and making them mixed numbers. So in the example, you can see how the number line is drawn and the arrow goes from 0 to 3, and then students are converting that 3 whole into fractional parts. So one way we talked about today is thinking about each one, what its value is. So here's 4/4, 4/4, 4/4, which is like saying 4/4 3 times, which we know would be 12/4. Or students can simply count out each of the marks till they get out to 3, which they would also see as 12/4. To get the final answer, though, they have to think about 3 and 1/4, and as you can see here, they took the equivalent to 3 and then added on the 1/4 fraction to come up with the improper fraction of 13/4. So students are going to want to do that number line activity as well as show the number model. So I'll come down and work on C to give you a chance to do some other problems yourself. One of the things that we want students to understand is that we're going to start at 0, but this fraction tells us that this number is between 5 whole and 6 whole. So for our number line, we'd want to come all the way out to 6 whole. And then students, of course, want to include the whole numbers first. And as you can see, I like to number mine so that I can clearly see them. And then I like to use the strategy that they used in the example, which is just putting dots for the number. Now in this case, we have to use 8s. So there's going to be some really small dots on here because there has to be 8 between each whole number. Okay, so this one's, your student may want to make the line a little bit longer. We know that we're going to do the same thing. We're going to show from 0 to 5, and then 3/8, we're going to come out 3 dashes. So I know this is 3/8. I know this is worth 5. I want to think about what the value is fractionally between each whole number. So from here to here, there's 8/8, and this pattern continues. Each whole number has 8/8 within it. So I can either add 8/8 together 5 times, find my answer, or I can say 5 times 8/8, and I would say that's going to be 48. So the number model can say 48 plus 3/8 gives us a total of 43/8. And again, you can do this whole part like they did up here and say 5 plus 3/8 equals, and so this is substituting, of course, for the 5. This remains for the 3/8, and then we're adding these up to get the final answer. So students, that's a couple different ways they can do it. If it really comes down to it, they can actually just count all the dots as well. That's also a strategy that works. So they can either add the whole unit, 8/8 plus 8/8 plus 8/8 plus 8/8 plus 8/8, or I like to do the multiplication because that seems a little more effective. On the students are going to kind of continue a trend that we started in class. You can see here this represents what we just talked about on the front with the number line, that we're doing 3 times 4/4, which then translates to 3 times 4/4. So this is just a process of taking out the whole number, multiplying it by what makes one whole. That will depend on the denominator. So in this case, 4/4 would be one whole because the denominator is 4. Adding in the remaining fractional part, which we see here and here, and then combining those. So saying 3 times 4/4, this now becomes 12/4. Added back our fractional part of 3/4, you can see the total here is 15/4. So what I would tell students to do is first break each mixed number into whole number and fraction. Then they need to think of the whole number times what makes a whole. In this case, I know it's 3/3. From there, I'm going to continue to add, that should say equals, 2/3. And then all I'm going to do here for this final one is convert. When I convert, I want to think of what is 5 times 3. That's going to give me 15/3. I'm still needing to add in the 2/3. So you should be able to see this process here. 5 became 5 times 3/3, which is 1 whole, or 5 times 1. The 2/3 remains in the problem. The 5 times 3/3 became 15/3 because I multiplied 5 by 3. I have 3 whole, and I have 5. 3 make a whole, and I have 5 whole, so I have a total of 15 parts out of 3. And then this 2/3 just continues to be added to the problem. When I do that, I can see that now I'm ready to solve for the improper fraction. 15 plus 2 is 17/3. So I'm going to come down and do D with your student, and you can try E on your own. So remember, first break it into the whole number and fraction. So what would you write for that? The whole number is 3. The fraction is 7/8. What does that equal? Well, if we have 3 whole, we want to multiply by what makes 1 whole. So look at the fractional part, what makes 1 whole? It's 8/8. From here, I know I need to continue to add my fraction part, which is 7/8. Now is where I take the 3 whole times the 8 parts that make a whole plus 7/8. That's going to give me 24/8 plus 7/8. And then my last step is to combine the numerators. Excuse me. So in this one, we're now using the ability to take mixed numbers and make them into fractions. So we can follow the same process. If I know I have 2 whole, I want to think about what makes 1 whole. So I want to say 2 times 3/3, or I can skip count. 3/3 makes 1 whole, 6/3 makes 2 whole. This is going to give me 6/3. That's only thinking about 2 whole. I still need to add in my 1/3. So I'm going to end up with 7/3 in this case. Okay, let's try one down here with 3/5 with just skip counting. So 5/5 is 1, 10/5 is 2, 15/5 is 3. So each of these 15, oops, it should be fifths, not thirds. 15/5 represents 1 whole, or 3 whole, excuse me, plus the 2/5 in the mixed number, give me a total of 17/5. We always want to remind students that when we're adding common units, we keep the denominator. So students are going to want to either skip count to figure out the whole, like I did here, 5, 5 more, and 5 more is 15, and that's representing the 3 whole. Or students can use this idea of multiplication. 3 times here would be 6/6. We'll give them 18/6. So they can do multiple methods to solve these problems.